everybody, and welcome to another Geo-Institute live stream. My name is Christina Scott. I will be the host for today's Our Scour episode 4. Before we move with our moderator, which will be Stacy Kalisa, and our guest, Jerry DiMaggio, I would like to remind our new viewers that who we are, who is the Geo-Institute. We are part of the American Society of Civil Engineers. The American Society of Civil Engineers have 9 technical institutes. We are part of those institutes, but we also have technical activities. If you want to know more about the Geo-Institute, about the ASCE, the regions, committees, technical activities, institutes, you can visit asce.org. If you want to know more about the Geo-Institute, the GI chapters, technical committees, board committees, student opportunities, you can go to the geoinstitute.org and check it out, all the information we have in our website. You also will find the student participation region. If you go to that window, you can find that you can get a gift if you make a donation. We start to get a gift. The donations are starting $25, but we also have this limited additional roll pack bobblehead. To get one, you can visit the Geo-Institute website and the Student Participation Fund and choose the roll pack bobblehead, and you will get the bobblehead and a pin. If you are out of the States, shipping and handle may be different, so just so you know. But this will help our students program. So please visit the website. And if you are a student, feel lucky because we are working for you. Other than that, I would like to introduce our host for today, all the way from Texas State University, Dr. Stacy Kalisa. Hi, Stacy. How are you?
Good, Christina. How are you?
Doing well. Happy to be here.
Yeah, me too. Thanks for that. So thanks everyone for coming back to episode 4, Hour of Scour. I am Stacy Kalisa. I'm associate professor at Texas State University. I'm also the director of our CREATE University Transportation Center, which focuses on coastal infrastructure durability, and that involves a lot of scour. And so given the opportunity to come and only talk about scour, couldn't pass it up. I'm sure that everyone has been watching every episode, but if not, for a quick recap, episode 1, we talked to Jean-Louis Briot, kind of the original researcher, right, in terms of why geotechnical engineers should be involved in scour. Episode 2, we talked to Nina Stark. She talked about coastal erosion and coastal scour. Episode 3, we talked to Rodolfo Sancio, and he talked about ice scour and ice scour in a ranch in South Texas. So that was pretty cool. And today we have Jerry DiMaggio. So Jerry comes to us back, he was a principal bridge engineer and the project program manager for the Geotechnical and Foundations group at the US DOT. Then he retired in 2008, but we were just talking, he decided to keep moving. And so he went to the National Academies, after which he was at ARA. And in 2024, he moved to HNTB, which is his current role as a civil engineering and construction services consultant related to design, construction, and long-term performance of infrastructure. And we thought it'd be really fun to talk to Jerry because of all his... Jerry, could you tell us, how'd you get into scour?
Well, first of all, let me thank ASCE and GI for inviting me to join you today. And since I owe Brad Keeler a lot of money, so when Brad grabbed me at this year's TRB meeting and he said, "How would you like to do me a favor?" And here I be. So thank you, Brad. And it's always a pleasure to work with ASCE. So how did I get into scour? Well, when I was younger, I was going to lie and say I was handsome, but I was taller, definitely, back in those days. So there was this first exposure to the Scour River Bridge that collapsed. And though not everybody's familiar with the history of that, I was not involved with the bridge itself. It was New York State's throughway. It was on spread footings, and it was on a cemented sand. And not everybody joining us today is a geotechnical specialist. I think that's important as we talk. We probably have some structural people, we have some hydro people, we've got some construction people, and then those geo people, geologists, engineering geologists, and geotechnical engineers. So I'll try and answer questions that it's a bit more generic as we go along. So it just struck me, and I shared this with Stacy when we first started to talk about my involvement with the Hour for Scour, is that the week before, and I swear to goodness, this is not a lie, due to some budgetary constraints, there was serious consideration that the Turner Fairbanks Hydraulics Laboratory, which had been in existence for a number of decades at that point, was going to be shut down. And so the moral to the story is something bad happened and people lost their life with regard to the Schoharie River Bridge, but the salvation was we continued to do excellent work. Sterling Jones and my very good friend Cornell, both of whom are retired now quite a while, did some fantastic work in hydraulics and scour and stream stability.
So you said you weren't involved in the collapse, but just learning about the Schoharie Creek, that's how you started to be more engaged with scour, or where do you go from there?
I think my appetite was whetted, so to speak, based on being inquisitive to the Schoharie River Bridge. But as I dug deeper into it, and some of this still continues today, the first revelation to me was that scour, at least in terms of my career, was the first interdisciplinary problem that we had to deal with. And now we have a multitude of those, and we'll get many more that we haven't even thought of. But if we think about scour for a minute, it involves the disciplines that I just mentioned that we have in our audience today. It begins with the hydraulic friends. It then cascades over to foundations and geotechnical engineering. The structural people obviously get involved for unsupported lengths and buckling and things of that sort. And then our good friends in construction, contractors and inspectors and construction engineers on both sides have to build what's designed. Now, you would say, well, that's exciting. These four groups are working together. Well, theoretically, sometimes, yes, they do, and sometimes they don't. One of the problems that we begin with is we all speak each of those disciplines in somewhat of a different vernacular. We have our own language, and we don't think of it in that sense, but we kind of look at a common problem such as scour, and we look at it differently, and we use different terminology. So everybody's heard about, we work in silos of ignorance. A preferred term really is we work in cylinders of excellence. Right? That's more true and that's more correct. Well, we've made great progress getting those disciplines to work together and better understand each other. For an example is, I'm a geotechnical specialist and I'm doing a foundation design. What should I communicate to my hydraulics counterpart on a bridge crossing, a bridge water crossing? What do I need to do my design? And for a very long time, there wasn't this communication that occurred. And I'll just dwell on that, if I may, for a second, is that the hydraulics folks did their job, and they always do it well, without doubt. And they pass a number along to the foundations people without really knowing how the sausage is made from the foundation side. So one thing that's occurred, and this has occurred progressively, and I think it's generally in place today, we have a better communication across the disciplines for most projects.
But correct me if I'm wrong, and maybe things are changing, but my understanding is that sometimes still, if we're going to design a bridge, the first thing that happens is we do our scour analysis potentially before we even know like the alignment or where the bridge might be. You think that's changing, or? Well,
this all boils down. Actually, I was going to be an attorney. I became an engineer by accident. It all comes down to communication.
Yeah.
So you're absolutely correct. Is before the final span lengths are set or before the bridge alignment is set, the hydraulics people may do an analysis based on their preliminary evaluation. And like most of the problems that we have today related to bridges, it's an iterative process. So it's fine if an initial number is created, but that number is probably, in many cases, nowhere near what the final number will be, either for local scour or for channel degradation or aggregation, et cetera, et cetera.
Right, because we potentially haven't even drilled boreholes. So then you're just making an assumption on maybe a minimum particle size for that first analysis, right?
Yeah, and now that you bring up that point, so if you were a geotechnical engineer and you look at our typical gradation sieves that we like to focus on, like a D60, D10, D15, et cetera, the hydraulics people use a different number in terms of their sieve size. So there we have a little bit of a conundrum in terms of a different language, as just one minor example.
Sure. I want to go back to your comment on, they give you the number. So if you are, I guess, a structural geotechnical engineer, you keep that hat on. How many scour numbers do you think you need, or how many scour numbers would you like? And what do we mean by different scour numbers? Is there not just one number? I've just asked 5 questions.
Well, I'm an only child, so I have a big need. I want a lot of things. So I think to answer your question correctly, I have to say, first of all, we have to look at different storm events. And today, the code may change as things are changing hydraulically in a catastrophic. I'm dealing with some Helene repairs right now. So we're doing a repair and it's got a 1,000-year event. And that would have been not so long ago unheard of. So 2 numbers right out of the gate, not to be confused. Currently, we're going to look for a 100-year storm event and see what the scour is. We're going to look for a 500-year storm event and look what the scour is. So that's on the hydraulic side. What I'm going to also look at is what's the general degradation of the channel based on the overall footprint of the final bridge. And that's usually established kind of maybe the 60% design stage. And then I'm going to look at local scour, because every multi-span bridge that's crossing water is going to have some piers. So I'm going to look at the abutments and I'm going to look at the piers, and there I've got a local scour and I've got general scour. So let's count this. Let's make it easy and say that I've got a 2-span bridge, right? I've got 1 pier and I've got 2 abutments. So I need 3 numbers for that. Then I need a 100-year event. I need a 500-year event. And then geotechnically, the next question might be, what do I do with that? And how does the general scour differ from the impact of the local scour in terms of the stresses that the ground sees, and whether they're temporary or whether they're permanent?
Sure.
So it gets to be pretty complex. Now, let's take a step back for a minute and say we began with the hydraulics people generating a number in a cylinder of excellence, passing that number along to the foundations engineer, and now we have a multitude of numbers. So obviously communication has to occur.
Sure. And then hopefully, based on what you said with my first question, that they might even come back and update their number, right? So now we've got actually have a little bit more understanding of the soil properties. Should you go back, would you like to redo this analysis or give me an updated information? Or do you think that happens a lot, or hopefully?
Well, I think today it probably happens. Back in the old days, and I don't know what the old days were, I would say before certainly Scour, and then after Scour for a certain period of time, is that the hydraulics people often did not even ask the question of whether rock was scourable, or if there was a change of time related to the type of soil, that it would be a granular soil, cohesionless soil if you choose, or was it an over-consolidated clay? And if it was rock, how rotten was the rock, right? We've got rock in the United States. Rock definition begins with unconfined compressive strength at 1,500 PSI, and there's some rocks in the U.S. that exceed 50,000 PSI. Now, some of that rock is scourable and some it's not.
Yeah. And then where do the IGMs fit in, right? Your intermediate geomaterials in terms of scour.
Yeah, so I personally
New question.
prefer the regional geotechnical materials, but my very good friend Dr. Dan Brown coined the intermediate geomaterials because, and what that means for the audience of lay folks that are out there in some geotechs is that if we pick up a textbook, and this will be obvious when I say it to the geotechs, and we look at these nice divisions of cohesionless soils and cohesive soils, and let's stick with cohesionless and say it's loose to extremely very dense. Well, as you travel hither and thither or fro around the world, but let's take in the continental United States, we've got lots of regional deposits that don't quite fit the soil mechanics and the rock mechanics models that we use routinely, that we get from good research, and we have for over 100 years now, or nearly 100 years now. So where do those materials fit? If you're ever stuck for an answer to an engineering question, you can always look smart in front of your colleagues or the professor by saying, it depends. And Stacy, this is a very appropriate time to answer your question, as it depends.
Sure. That's okay. Fine. I'm going to go back to something, but I want to point out something that we neglected. Everyone is welcome to ask questions, and we have folks monitoring the chat. So if we say something that tickles your ear and you want to follow up on it, or just go off an entirely different tangent, please ask us a question, and we'll be sure to ask Jerry for his expertise or thoughts on that. But if we go back to, so were you at USDOT when Schoharie happened?
So Schoharie happened in, as my age gets about me, I believe that was 1987.
87.
Okay, and I joined Federal Highways after I got laid off from the state of New York, but that's a story of another day. I joined in June of 1976. I joined the Federal Highway Administration.
So
I spent my whole career there after I was told numerous times, you stay here for 2 years in Washington, and then you move to a region or a division, and then you hop around to get promoted. And I spent 32 years in Washington. Either I was dumb or I was smart, but all I did was change offices in 32 years.
Did you get bigger windows?
I got 5 promotions in place. That's what I did. Yeah.
Well, so since you were there, how did our approach? Because before Schoharie, we didn't consider Scour particularly at bridge assessments, right? Or a bridge when we would go out and inventory bridges, right? Correct. Before that failure, we didn't really. Is that the big change that came for? I just want to know, how did that start? Because that's always the starting point for everyone's conversation in Scour.
Well, that's interesting because we're going to get into one of your topics of expertise, unknown foundations.
I don't think I want to guide us there.
No, but it's important that, it historically, for very simple reasons, the bridge inspection program did not have the focus that it does today on the foundations. And I said for very simple reasons, because a lot of the foundations are difficult to assess for their condition. They require non-destructive testing and remote evaluation and all of those good things. And I think we got into this a step at a time. Nowadays, I believe that the current component evaluation in the national bridge inventories, and I'm not involved with that stuff really at all anymore, is as focused on the foundation and the substructure as it is on the superstructure. That was not always the case. In fact, there was a time, and I think it was several years after Schoharie, in fact, maybe 8-10 years later, somebody in Congress noticed that in the bridge inventory, we had in the data that was being reported to Congress that there were 15% or 18% of the bridges were noted as the foundations were unknown. So not only did we not evaluate them, but we didn't know what type of foundation there was. And that caught the twinkle in somebody's eye in Congress, and Federal Highways was mandated to initiate a number of activities that were related to better knowing what the foundations were, what the conditions of the foundations were. And that was a very good thing. I mean, it took a lot of work by a lot of people, I was involved with that to some degree, and you were involved with it later on. Yeah, while you were going to graduate school, I believe, and you probably still are involved with it.
Well, I mean, that PhD topic, you can never really let it go. Every once in a while, you have that talk already prepared. You got to like bring it back out from the depths. But it is kind of fun to think of it as an evolution. I mean, I was born a little bit before Scour, and I went all the way through straight to my PhD. And yeah, it was a research topic of interest to identify unknown foundations in 2009 is when my project started. And that was because it took all the way until 2008 for that mandate for all states to have a plan of action, just of what they were going to do, right, to evaluate to identify their foundations. And at the time, Texas had the most. We had over 9,000 bridges with unknown foundations. Not the most like per square mile per se, because it's a very large state, but the most quantity. And that was one of the ways I think TxDOT came at it, is they said, well, let's do a research project on what's the most proficient or efficient method to identify the type and depth of unknown foundations. So it was fun. I told them, I always tell grad students, I was very much like a troll, and I might go and just hang out underneath bridges all day long. And I did it in the summertime. And so it's much cooler in Texas under a bridge than it is on top. So it wasn't a bad gig, certainly. But it's been an interesting thing that's evolved. Christina, did you have any questions or other questions from the chat? I thought I saw you unmute and then I just kept talking.
Oh, no, that's fine. I don't know if we have questions yet, but talking about rocks, and I know, Jerry, you have been working all nationwide. When we have in the Caribbean, I'm going to talk tropics. When we have rocks and then the rock is exposed, it weather very, very, very quick, really quick. So 24 hours, 48 hours, you have a layer of soil, maybe 1 inch already weathered. So we have some problems in Puerto Rico with some bridges, and my background is geology. So I never studied scour. I was more like erosion, deposition, like how the Meander River works or behave. So now thinking about, bridges, like how deep is the rock. So do you never encounter a project where the rock was so weathered or the joints were so deep that you need to cut and continue cutting until you get a hard ground or hard rock?
Yeah, and you specifically said your rock, you're from Puerto Rico, so you were referring to the rock in Puerto Rico. Now, I've done a lot of work in Puerto Rico over the decades, and I don't think all the rock is quite that weathering susceptible. I know you have some soluble limestone, which is a whole nother problem. We could have an hour of karst topography sometime in the future.
Doesn't rhyme though.
Yeah, but so I'm working on a couple of projects now in West Virginia, and West Virginia comes to mind, where a lot of their clay stones and mudstones are really hard in place. So hard, in fact, that from an excavation point of view, they have to be blasted. They can't be ripped. So they're very hard rock, but as you correctly pointed out, once it's exposed to the moisture in the atmosphere, it breaks down to a clay. And that's the nature of some of those materials. And they certainly would be very susceptible to scour in a short period of time. And that's something we really haven't talked about, is the time-related factor. Is some materials are going to be more scourable in a short period of time than other materials will be.
Yeah. It changed so quick that, we have the cut, it's a dark brown or a dark gray color rock. And then the next day it's red, but a reddish brown, because, but I'm talking about the center of the island where we have like the igneous rocks. And, but again, it's like so weathered, and you can tell after a heavy rain, which is every day, the runoff is so big. Like I am in the mountains and I can see the ocean, and I can see the plume, like all the soils, getting to the ocean. So, so again, I don't know how they handle the infrastructure. I know we have several bridges, But again, it's like, I don't know how they manage that part. The installation, I think, is my question.
So and you probably, the two of you are familiar with the rock mass rating system and the GSI system for rock classification. So the rock you just described, I have my own Jerry system. I call that rotten rock. Yeah.
That's funny. That's cool. I will use that too. I don't know if we have questions in the chat, but I would like to encourage everybody to join us and add your questions in the chat, so we can pass it to Stacy.
Yeah, or you can ask a question.
There we go.
Yeah.
Yeah, and Stacy's got a couple more questions, I think.
I do. I have questions out my ears. So we didn't. You mentioned when you talked about Scour that it was on sand, right? And it was on spread footings, and it was undermined. How big was that scour hole?
I don't remember, but it was on the key thing that you left out. It was on cemented sands. So
Cemented
we
sands.
did the subsurface investigation, and honestly, I mentioned before, a bad thing like Scour, where there was loss of life, led to a good thing with the FHWA lab. The other bad thing with Scour was, I think it set back the concept of use of shallow foundations decades. And there's a right place to use shallow foundations and a wrong place to use shallow foundations on either soil, or I would say not rotten rock, but not really sound rock. But we're still fighting that battle to kind of, and it costs a lot of money. I mean, I've got projects now where we've got 8-foot diameter drill shafts, not saying that I could use a shallow foundation. I got an 8-foot diameter drill shaft going 250 feet in the ground. That single foundation element is probably $300,000. So, we only got so many jelly beans that we can spend on infrastructure. So we've got to do as good a job as we can and keep things safe and durable.
And so when I think back to my literature review when I was a PhD student, if you look at it was Scour, and then it was in terms of the ones that kind of happened rapid fire and unfortunately all results in loss of life, Hatchie Creek and then Los Gatos. Those were kind of the three that I remember anyway, within a kind of a 10-year period. But Hatchie Creek was different, right? It wasn't.
Yeah, Hatchie Creek and I think the Bonner Bridge problems. Now, Bonner didn't collapse, it got replaced. But so let me talk about really Hatchie and Bonner together, is that I've got a multi-span bridge, and I've got an environment where I have strong hydraulic events that are going to have high velocities and a potential for scour. The unique aspects of those two bridges, just as examples, there are many more, is it's kind of like whack-a-mole. So whack-a-mole in the sense of saying, I know where the main channel is. So I'm going to take the 2 or 3 main piers or 4 piers around the main channel, and I'm going to do my scour evaluations, and that's going to give me a secure foundation. Now, maybe I've got another 20 or 30 or 40 other piers that I have to deal with. And guess what? 5 years from now, whack-a-mole has occurred and the main channel has moved. So I've got to be very cognizant in those environments that during the life of the structure, if it's a critical structure, it's got to be designed for a minimum of 100-year service life design, that I've got to be thinking hydraulically and scour-wise, what's the potential for a meandering main channel, so that I've got all of the protection I need on all the piers during the entire life of that feature. That's extremely important.
Sorry, my mic dropped for a second. Yeah, so that was what was different about Hatchie, right? That was the first failure that was caused by river meander. So kind of a new problem that's kind of unfolding in terms of how many numbers you need.
Yeah, that's right. Because if I'm myopic in my thinking, then I'm focused on it, and I'm not thinking of the possibility of really what's happening. is, there's another consideration. I mentioned the Bonner Bridge at Oregon Inlet, and then the Indian River Inlet in Delaware, which is only about 4 miles from my home in Rehoboth Beach, is that those two inlets, for my money, on the East Coast and maybe across the entire country, the velocities, because they're inlets of that water, and I would say this, and when I was working on the Indian River Inlet, if God forbid you fell in the water in Delaware, you would end up in the United Kingdom. The velocity was so strong, it would just, obviously that wouldn't happen, but
wow,
tremendous velocities.
Yeah.
And that's another specialty area in terms of looking at the hydraulic side of the house.
Yeah. Okay, good. So we're starting to get questions from the audience, which is good. So we'll kind of hop around.
Well, I hope their questions are good as yours, Stacy.
They are better, actually. I'm going to go in no particular order here, but it kind of pertains to what you were just talking about. So when you talked about bridges and long-term degradation, can you define what long-term degradation as it pertains to a structure with a 75-year design life? What processes should we be concerned with?
So if I'm not really sure I'm answering the question, but I'll take a crack at it, and then somebody could rebut on their questions and come back with a follow-up, is that when you're looking at a 75-year service life, now, and I've gotten into the habit, I speak more intelligently about service life than design life. I think those are very different terms, which is a whole separate conversation. Is you should be looking at hydraulically, and that's not my specialty area, what is your estimation of going to happen hydraulically at that particular site for a 75-year period? And you say, well, I take a wild ass guess at it, excuse me, but I take a wild ass guess at it. But what I really should do, and this is growing and it's getting into the area of resiliency, of resilient-based design, is look at the historical data, apply probabilistic statistical models, and we can use all of the historical data to make predictions of how bad an event will occur in the future. Of course, we don't know what the future is, but generally what we see, and it applies to hydraulics, but I think my poster child for this is seismic loading, is what we see in practice due to extreme events is the frequency at which an event occurs, that's our design event, and the magnitude of the loading associated with that event, or Scour in this particular case, seems to become greater with time. And you would say, well, that's a no-brainer. But if I look at a body of data over a historical period, that gives me enough data to make a predictive model based on probabilistic theories. And that really has not caught on yet. I think there's a bit of that. God forbid we have another major seismic event, is an anywhere in the world, is we look at that seismic event and we generally say, okay, now we got to modify the code because we're going to learn something because that's bigger and more destructive than the last one we had. That's probably not the best way to look at it. I think you're going to see more people look at bodies of data and probabilistic modeling for futuristic predictions.
Yeah.
I probably totally blew the answer there for that question.
But we went in a fun direction, and it kind of goes for this kind of follow-up of reliability. What information do you wish designers or owners gathered earlier to make evaluations more reliable?
Well, I think it's doing desk studies, making and we've got a lot of historical data. I think people in my practice, and when you get old, you hear this old cliche: old people get cranky. Okay, and maybe it's my crankiness coming out, but I don't think we make the most of the knowledge and the data that we have based on desk studies as we could. And maybe what the owners could do is to better assemble that information to where it's more accessible to the design team. Maybe they can, maybe they can't. And maybe it doesn't exist in some cases.
Ooh, maybe I can derail us in an entirely different direction, but that's like the idea behind digs, right? Or some of the idea behind digs, is it not?
Yeah, but that's only one aspect of it. I mean, we're
Yeah,
talking about, I mean, there's all kinds of collective data. I mean, look at what we're doing. Think about the body of data that we have when we do pavement evaluations. We've been collecting pavement data, I think, about 55, 60 years now. We've been collecting bridge data for 55, 60 years. I would argue strongly that we probably don't fully utilize the benefit that that data can provide us in making future predictions of what we need to do better as we go forward.
Yeah. It's a great asset management challenge, right? Because you're right. You can use statistics if you were to build those into some type of model to understand not just the extreme event and making sure, but statistically what we should be better prepared for if we actually use those.
Mm-hmm. I mean, I believe that, but
I'm with you. I'm sold. You got one more believer.
That's two of us.
There. Christina, you want to join the bandwagon?
Of course.
Okay, good. All three of us are on board. If we go back, I like this one. We're going to get to this other question, but this one's near and dear to my heart. What are the pros and cons of physical versus numerical models for Scour analysis? And this is even more fun. Which is generally preferred? Which one do you like? Which cookie do you like?
I'm an only child, remember, so I like them both. But I think what you have to realize, and I don't mean you personally, I mean, and I'm being old and cranky, is every model that we do, whether it's a scale model or a full scale model, or if it's an analytical tool, finite difference, finite element, two-dimensional, three-dimensional, everything has got a set of limitations and boundary conditions over which it's going to give us reliable output. And I think sometimes out of desire to come up with a good answer, whatever that is, I think we forget those limitations and those boundary conditions. And, is there something wrong with a physical model? I mean, the mechanics is, if I take a physical model related to Scour now, and I've got some soil in a flume, and I'm not a hydraulics expert, remember that. So if I misspeak here or you disagree with me, feel free to push back. I don't have the same mechanics from the effects of gravity, the effective stresses, the models that I can create. If I use a fine sand, well, that fine sand in a flume is going to behave extremely differently than it's going to behave in a real riverine environment. I mean, that's a limitation. So as long as I know that doesn't mean the model's bad. It just means I got a limitation.
Yeah, I got to, we have a flume in the hydraulics lab, and they only use it for one teaching lab a year. So I started running flume experiments, and pretty much everyone I've met is like, the hydrologist lets you put sand in the flume. And I was like, yeah, we put a sock filter over it. Like, it's fine. And it was really fun to go, but, and we tried to keep it to where basically we're just comparing apples to apples, because it's not, if I wanted to compare, we were looking at scour mitigation with an alternate kind of to riprap. So I could certainly compare apples to apples, but it's apples to apples with this very loose sand and this very small flume in unidirectional laminar flow. Yeah. And there's nothing there that's, so it's valuable, right? Some models are useful, but all models are wrong, or something along those lines. I said it backwards. But you're right. There's certain limitations, and as long as you accept that, it can still provide a lot of insight, I think. Okay, if we go away from research, Jerry, what's your favorite part about working on the Hurricane Helene projects in Western North Carolina? Maybe it's from a local. Maybe it's the barbecue.
Well, I live half the year in North Carolina, so I like the bar. Well, I got to fess up, and I'll probably be kicked out of Raleigh here.
Watch out.
I like Texas barbecue better myself,
but I think the people on this call are okay with that answer, but
okay. So the Helene disaster is, I've seen things that I've never seen before in my 54 years of practice, and I'm in awe and I'm frightened with the level of disaster. And not only the effects on people, but the effects on infrastructure are incredible. And I think we need to think more about what's going to happen in the future for the service life of our infrastructure, whether it be highways, whether it be rail, whether it be hydro projects. I think we're in an era where the rate of change of things is going to accelerate. So other than that, I think we've got a fantastic team working on the projects that we have doing the Helene repairs. North Carolina DOT, I've done a lot of work with them. They're one of my favorite highway departments to work with. So I'm trying to get myself back into Raleigh so I don't get kicked out of my house. No, but I don't know what else there is to say about that other than if you look at the devastation, and I've seen a lot of failures. It's pretty frightening.
Yeah, I agree. Let's go back to Christina. You can both answer on this one. Apart from the extreme rock, which is rotten, and invincible, so unscourable, does the science help us with the time rate of scour of rock? Or is there science that can help us with the time rate of scour of rock in the in-betweens, I guess?
Go ahead, Christina.
Well, on my part, we can test the rock, but it's sometimes unpredictable. It's all depending on the energy of the water. So I think like having other scientists and engineers together, we can understand better the behavior of the rock, but to know the rate depends. I think depends of the rock. You know, if it's a marble, it's going to be hard. But, so it all depends. Like if it have joints, if it's a sandstone, it's already weathered or was exposed. So no.
It depends.
Yeah,
so
that's.
You notice how that came up immediately there. So that's often, and she looked great. I mean, I don't mean physically, not that she doesn't look great physically, but that was a very intellectual answer. It depends. And she's absolutely correct. Right. And so think about soluble limestone, which is very different from the clay stones and the mudstones you talked about before, is that it's not scours. So it's just turning from a solid to a liquid. But that occurs over relatively short period of times, depending on the changes in the hydraulic environment that we have, drainage projects. So when you look at a rock, I mean, and I have to admit, I was late to the party for discovering the sophistication and complexity of rock mechanics. So I was brought up in New York State by education as well as my early career. I thought the entire United States was glaciated when I had a delusion one time. But then I realized that rock is a much more interesting material from an engineering point of view than soil is in many respects. Now I'm going to be kicked out of the soils lab, I'm sure.
Yeah. That you are. Oh, I need to scroll down. I will derail us briefly just because I'm trying to process what this new question is. Someone asked if I'm related to Rich Kalasia. Don't think so. From Bechtel, just because there's only 2 Kalasia engineers that I know of, me and Michael, my husband. There's a lot of Tucker engineers, though. I was a Tucker before Kalasia. Back to Scour. Do you think soil near an abutment or at a riverbed doesn't just break instantly, but slowly oozes and creeps under pressure? I would interpret that is Scour like an instant process, or is it something that's going to be time dependent?
Well, it depends on the soil.
Yeah,
so
it depends.
No, but seriously, if it's a granular cohesionless material, then it's going to be occurring quite rapidly. If it's a heavy over-consolidated soil, and I hate that word over-consolidation, a strained hardened material, then then it's going to take a longer period of time. And the degree of which it's strained hardened, to talk in basic engineering terms and not talk about consolidation, because some people online don't know what consolidation is, and I don't mean that the wrong way, it's just they're in a different discipline, is it's going to take time. And, something we haven't touched on is how do I measure the scour depth after a storm event? And I'm sure, Stacy, you're going to get into that question, but it's like a problem with local scour is after the storm event, the scour hole fills in. So
Yep.
How the hell do I know what the depth of the scour is?
Yep.
It's like we've mastered that problem, but it took us a while to master that problem.
Yeah, scour infill is a fascinating adventure, let's say, to talk about. I think I've mentioned it on here before, but I'm going to say it again. One time I was training my grad student how to use some marine resistivity equipment, and our project is to we finished the project, but we were playing chicken with boats, deep draft vessels in the Gulf of Mexico, which was awesome. In the Houston Ship Channel, a boat would go by and we go flying behind it. Yeah, we were getting these marine measurements, but I hadn't used the equipment in that way before. And so I wanted to simulate it in the river. So me and my blessedly trusting grad student went in the river with a kayak, and I dragged the kayak up the river while he was on the other end. And that was our simulation. And when we were doing it, he's taller than me. He's probably 6'3", and he fell in a scour hole. Like I saw my grad student go down underneath the water. But then from our results, you could see the infill at this bridge site. So because it was a resistivity measurement, and just because of the soil type that it had, the river bottom was actually very clayey, but the infill material was this loose kind of rocky sand, and you could see this very distinct scour hole and then this thin layer of infill material. I wrote a paper on it, and it was kind of fun because I was just training my student how to use our equipment. But you are right; they have worked on that problem for a while with ground penetrating radar and with chirp sonar and different systems that can go through and can detect different materials. And with all geophysics, what will work somewhere will not work somewhere else, and so it's good to have because you just need different contrasts for geophysical methods to work. Anyway, that's my side story into ASCE. I had to make sure my grad student could swim before we did that. I did check that first.
So Stacy, I don't know you well, but I know you long enough. You've got to promise me you'll never do that again, because now you're the mother of two very young children. Yeah. So no dangerous stuff again. Right?
Which thing do you call dangerous? The chicken with the boats or the kayak?
You could pick either one you want.
Both. I had a safety vest on. I mean, we were in the water. So anytime you can do any field work and be wearing your swimsuit, it's a good day, in my opinion, to be out in the water. It's much better than sweating out in the middle of some field, which I've also done to get samples. So no promises there. Do you think our scour models or analyses and historic information will need to be revised due to global warming changes? Do you think our practices should change, I guess?
I think our only, I guess two things come to mind. Number one is already integrated, at least in terms of FHWA's hydraulic engineering circular series and other documents. Probably the Corps has some. I'm less familiar with all the Corps documents, of which there's mountains of them, is a risk-based approach. And, when we look at we have in the United States, in round numbers, 620,000 structures, bridges. I believe I'm correct that about 75% of those are crossing some body of water. And when we look at existing facilities as well as new facilities, then I think we've got to take a risk-based approach. Simply, there's not enough money to do a Cadillac or a Mercedes at every single location. I believe that's one. The second major change we've already touched on a couple of times is I believe that the storm events will continue to become larger with an increased frequency of occurrence. And I don't know anything more than anybody else on the line today, but everything that I see and hear and read suggests that the Earth's been changing for billions of years. So suspecting that it's not going to change during the, let's say if I live to be 100, which maybe I don't want to be 100, I don't think I do, but over a 100-year period to anticipate that there's not going to be any change in climate conditions is absolutely insanity.
Okay. Yep, you're right, Jerry. The climate is unpredictable sometimes. So I have one more question in the chat. I will I don't know if it applies to this conversation. How will the concept discussed be best applied to a utility scale? Very large solar site with hundreds of thousands of driven piles that have localized scour at the individual pile soil interfaces. Pretty long question.
I'm not sure I fully understand that. I couldn't get all of that question. I'm sorry.
How will the concept discussed be best applied to a utility scale? Very large solar site with hundreds of thousands of driven piles that have localized scour at the individual pile soil interfaces. So it looks like the scour is at the bottom of the piles.
Yeah, so it sounds like something where you've driven a lot of piles. Yeah. And you know scour is an issue, and so how would you address that when it's not an individual bridge pier but a large site covering a large area? I think that's what they're asking.
Okay, yeah, I hadn't thought of that question before.
That's a fun thought.
I guess, yeah, go ahead, go for it.
Oh no, you're the expert here.
Oh,
I'm the host.
I don't think the presence of the piles are going to change the effects of the scour or of the soil that's around the piles. I think, how would you approach the design? Then if you believe what I'm saying, then you have to look at the potential for an unsupported lane down to the depth. And that gets us over into the structural analysis side, the buckling and the unsupported length issues. But the presence of the piles, in my mind, is not going to be a scour mitigation measure unless it's particularly designed for that. I mean, we drive piles all the time for maybe not a forest of piles, but certainly we've got pile groups. There are many more bridges that have pile groups than we have monopiles or non-redundant foundations.
Yeah. I kind of want to go back because we're almost out of time, which is good because we still have questions, and so that's kind of fun. You talked about in our previous question how things are going to change, and you mentioned that we should go towards a risk-based approach. What do you mean? Like how what do you mean when you say our practice should evolve to a risk-based approach, practically speaking? What does that look like?
I think you could look at that in terms of more for the existing body of infrastructure that we have now for the bridges, as opposed to a design, and maybe it could apply to new design, or I meant to say new designs. So if generally it's an asset management issue, is that we look at ADT, average daily traffic, and then we look at the behavior of the particular water environment that I'm at. What's the potential for catastrophic events, even though I can design it for any event I want? I think we look at the foundation conditions in situ. And that's a topic we didn't touch on that, we historically, and this was a change that occurred post-Schoharie, historically, pre-Schoharie, the driven pile was the deep foundation pile of choice. And it's not the fault of drill shafts. Now we all know that we use drilled foundations much more frequently, in particular drill shafts, when we do have deeper scour situations for a variety of different reasons. So that change occurred. And where I was going is with a driven pile also in that same time frame, and if we go back a decade prior, 1976 or so, is the first major national promotion of the wave equation analysis in the pile driving analyzer. So what's the significance of that to what we're talking about? Prior to that, every construction engineer who was interacting with a geotechnical engineer was kind of advised that the more times you hit the pile, the better off the pile's going to be. So what that says to me in plain English, we've got a hell of a lot of bridges sitting on a bunch of piles that were damaged during the installation process because we beat the living bejesus out of those piles back in those days out of the knowledge base we had. We weren't doing it out of ignorance to do something bad. We just didn't have the tools we have today.
Yeah. I didn't think about that. Christina, we have time for one more question.
Yes.
Sweet.
And somebody's going to ask me if I'm related to Joe DiMaggio today, but I've already been asked that question, so I can't answer that one. Go ahead.
No, we're only focused on Scour, Jerry. This is the.
Oh, okay.
Yeah. I have an opinion on this question, so I want to know your opinion regarding Scour. What's best when you're designing for Scour? Using the empirical equations, like the NCHRP report 683 on bridge scour, or using like Jean-Louis' approach, like an erosion rate approach? What do you think is better?
So I think I'm wearing out. It depends. It depends really on the site. It's a combination of tools. It shouldn't be purely hydraulic. And it shouldn't be Jean-Louis' approach exclusively. And Jean-Louis is a very good friend of mine for many, many years. I think you look at a combination of techniques to make a final decision. And I think that's often across the board. And what I've learned in practice is not to have excessive confidence in one single approach or one modeling technique or one testing technique.
Yeah, I think that's a good way to think of it. I mean, not just Jean-Louis' approach. There's many different erosion devices, many different erosion rate devices. They all and it's important to know the limitations of those because each will impart a different hydraulic load, and your answer is going to be different. So you should try to match that with what you're. But if you have the budget for it, right, and you can do some type of measurement and then still do the analysis, why would you not want to do both, right? I think maybe the issue would be if you had a budget constraint and you could only pick one, but hopefully you're not in that bucket.
Oh, you had a schedule constraint, so that's another thing.
I never thought about that.
We have the need for speed.
Yeah. Thank you, Tom Cruise. Are we out, Christy?
Yes, so I will have one comment, and it's from the Raleigh office. They're saying, hello, Jerry, you're doing a great job. So
they're going to come knock on your door.
All right. Well, I want to say thank you, Stacy, and thank you, Jerry, for this great conversation today. I learned so much. Now, every time I'm in a bridge, I'm going to think more. And I'm going to look around and say, okay, this area is more scoured, this is more deposition, etc. So to all our viewers, thank you so much for being so engaged in the chat. We really appreciate you stay with us, engage. To everybody watching, if you are not already subscribed, please subscribe, like, share. Our next live stream will be April 7th. I think it's next week. That's our business meeting with Dr. Susan Burns, our current president. Again, our viewers, thanks for being with us until the end. Jerry, Stacy, thank you again. And everybody, see you in the next one.